chapter 2, or unit 2, units and measurements. Right. So this is, we go with a simple introduction and how to measure the physical quantities, and we first go with fundamental physical quantities. Right. Now first let us say what is meant by unit and how it can be defined. Right. And simple logic, I am suppose if you are going to clothes store to buy a cloth, generally you will take the cloth and trying to measure it. You observe that one, a long stick is there. A long stick is there. What that long stick, by using that long stick, it is trying to measure, the class store person trying to measure the cloth. What is that? Obviously you can think of that, this is called as 1 meter stick. A 1 meter stick is there. So, and he will ask how many meters you want. So to length, the length of the cloth, if you see how many meters, you will ask how many meters. So in order to measure the length, the unit is called as meter is required. Of course, if you go to anywhere in the India, meter stick length is same. This will remains same. It cannot be altered. So that is simple unit, you know that. Next, if we go to grocery shop, or in our general language, kirana shop. Yes, a kirana shop. Then if you ask, or if you ask sugar, definitely you will ask immediately how many kgs you want. You say that it is half kg or 1 kg, whatever it is. So if you want to measure the quantity like mass, so kgs are required. Right. Next, suppose you ask to your friend to wait at a bus stop or some other location. Definitely he replies that how much duration and how much time I can wait, or should I wait? Either 1 hour or 1 minute or 1 second. So the time refers the time that indicates that in its, but in general standard, if you observe it here, 1 meter, 1 meter, 1 kg, 1 second are the units here. Of course, I can say that these are called as fundamental units. These are called as fundamental units, or we can call them as base units. We can call them as base units, right? Now we'll define major 7 fundamental base units and its symbols and all that. First we shall see what are the different types of systems are available. You know very well, I think in the previous classes you learn it. CGS system and FPS system and MK system and system of international SI unit. What CGS system refers? Here the CGS system refers centimeter, gram, second. FPS stands here foot, pound, second. And MKS meter, kilogram, second. And SI unit stands for system of international. System of international. Of course, this is a most frequent foot or feet. Foot or feet. Our heights are measured in feet. Heights, either you are 5 feet 5 inch or 5 feet 6 inch means 5.5 feet or 6 feet, or generally the measurements of a room can be either 12 feet or 14 feet. Generally we use this type of system generally, right? But this is a most frequent in scientific manner in calculations. We use meter, kilogram and second, and this is other type. Of course we can convert from one to other. We have some procedures to convert from one unit to other unit also, right? And before that I would like to introduce two quantities to measure the angle. To measure the angle, what are the units? Basically to measure the angle the units are radians. How to measure the angle and how to write the formula for it? See, this is a circle center O which is tracing a circular path like that, right? And this is a point P. P1, and this has been transformed to point P2, right? This is called as arc length. This is called as arc length. This is called as arc length. The angle traced at the center from one point to other point is called as theta or d theta. Angle is equals to arc length by the radius. Arc length by radius. So this is plane angle actually. D theta on the plane we are writing, right? This is a two-dimensional plane. d theta is equal to ds by r. D theta is equals to ds by r. So what are the units for a plane angle? The units for plane angle is radian. Units for plane angle is radian. And other units other angle is called as solid angle. Solid angle. This is indicated as d omega. See, you can see a plain paper. A plain paper. Just you fold it in a cone format. Right? Can be molded into cone format. So if you elaborate it, see that this is a apex O here, and you can see that this is like three-dimensional way we cannot draw, and this is right. Of course, this is radius r, and this is called as a spherical surface. The spherical surface with area dA. Spherical surface with area with dA. And once you see that this is the angle made at apex, which is called as d omega. Right. Now, how to define a solid angle? The solid angle, it is a ratio for what? It is a ratio of the intercepted area. It's a ratio of the intercepted area, spherical area, dA of the spherical surface by square of the radius. Square of the radius. Let's say a simple example, let us see. D omega is equal to intercepted area, spherical surface area is 4 pi r square divided by square of the radius r square, which is coming out to be 4 pi. So now the solid angle is 4 pi. So we have seen only the angle called as plane angle, and this is called as solid angle. Solid angle is like a three-dimensional view made at apex with the surface area. This is called as surface area. Now let us try to see what are the 7 fundamental physical quantities or base quantities. I can write it as fundamental physical quantities or base quantities. Fundamental quantities are base quantities. These are the quantities or physical quantities which are not derived from anyone, which are not derived from anyone. They are so fundamental, so basic. What are the so fundamental? What are the basic? First one, length. What is the unit for length? Already just we have seen simple example. Meter. What is the symbol for it? M. How to define a meter? If you go to Hyderabad, Mumbai, London, USA, everywhere, the meter is the same, that is universally accepted. That's what actually a system of international conducted a meeting in 1971 where for international usage in scientific and technical industrial like commercial works. So it is a accepted unit. How to define it? We will take a simple advantage of light speed. What is a light speed value? I think you might be know. Light speed, it is 3 into 10 power 8 meters per second, right? So exactly if you write it, light speed c is equal to 299,792,458 meters per second. Means for 1 second this much meters can be traveled, right? For 1 second the distance traveled by the light is 299,792,458 meters. If you want to get the time for 1 meter, now how many seconds duration? 1 by 299,792,458 seconds. So indirectly if I want to define 1 meter, the light traveled in a time of this, the distance traveled by the light is 1 meter. That's all. So how do I write the simple definition of it? The meter is the length. The meter is the length of the path traveled by light in vacuum during a time interval. How much time interval? This is a time interval of this is a fraction of seconds, 299,792,458 seconds. That's all. This is the meter actually. This is meter. The required time again. So of course in the exam they need not ask the definitions of what is the defined meter or that. This is a sample definition and how to define meter. This is so fundamental. Let us see the remaining uh, 7 fundamental physical quantities, and other supplementary are there we have already seen, that is plane angle and solid angle, right? Now first one we have already seen, length. It can be meter, simple is m. Second one is mass. Kilogram is a unit. Of course we can convert, that is simply we will write it as kg. Third one, time. Time, what is it? Unit is, don't write minute or hour, is a second. Simply we will write it as S is a symbol. Of course we define this time to be hyperfine levels of cesium crystal. That is different. We don't, they don't ask in definitions in the exam. However, first I should write all the 7 fundamental. And electric current, electric current, which is unit is ampere, symbol is A. Next, thermodynamic temperature. Thermodynamic temperature. Unit is Kelvin, symbol is K. Right? Of course, in the previous classes you had seen what thermodynamic temperature. Unit is Kelvin. Of course, Kelvin can be converted into Celsius, Fahrenheit. Yeah, I think you might have seen electric current, and that is amperes. Of course, the length, mass, time are very familiar terms to you. Next, amount of substance in the chemistry might have what, how many moles of solutions are required to mix a proper, to get a proper solution. Amount of substance, so which is called as mole. Symbol is 7th one, last one, which is called as luminous intensity. Luminous intensity, which is candela is the unit, and CD. Right? So these are all 7 fundamental physical quantities, base quantities. If any other quantity can be derived from these 7 only, and if any other quantity can be derived, that is called as derived physical quantity. Let us say length and time is there. Length and time, these two are the base quantities. In combination of these, length by time, which is called as speed, this is called as a derived physical quantities. Derived physical quantity. So we will see many of the derived physical quantities in combination of the all these 7. All these 7. Right? Now Of course, we will write dimension formulas for all these, and we will see the base fundamental dimension formulas and a derived dimension formulas we will derive in the subsequent classes. We will solve the simple problems also.